we want to graph this function and its derivative, and then we'll use the graphs to try to write an equation for the derivative function. So let's start with the original function, f of x equals the absolute value of x minus 2. So hopefully we remember that the parent function, the absolute value of x, is a v, and we have a shift to the right 2. So that tells us that once we shift to the right 2, we can create this function with our knowledge basically from college algebra of parent functions. So here's the original function. Now, when we go to graph the derivative, we need to remember that the derivative is the slope at any given point on the graph. So, if we analyze the left-hand part of this graph, which is a line, we know that the slope of the left-hand side here, this slope is -1. And in fact, my slope will be -1 all the way until I get to the vertex here at x equals 2. So I am going to plot y values of -1. So if my y value, think about my y value is always -1. So for example, a y value of -1 here, and here, and here. All of these y values, again, they're -1 because above the slope at this point is -1. And same thing, the slope at this point is -1, so we plot a y value of -1. And the slope here is -1, so we plot a y value of -1. So this means that my slopes are always -1 until we get to the x value of 2, where we have a corner on this graph. So the derivative is not going to exist here at x equals 2, which is why I have an open dot on the derivative. So I end up with a derivative that is just a horizontal line of y equals -1 for this part of the graph. Now let's analyze the other part of the original function, everything greater than x equals 2. So once again, if we take a look at the slope, we're looking at the right side. You can even think rise over run if you need to for slope. That the slope of the right side here is +1. And again, the slope is going to be +1 here for every single point that is to the right of x equals 2. So now we're going to be plotting y values of +1. And again, the slope is going to be +1 all the way, or I should say for every value where x is greater than 2. So that causes us to graph a horizontal line for the derivative of y equals 1. And again, the slope began, it was first a +1 slope when we had x equals 2, or rather I should say at x equals 2 is where the slope changed from -1 to +1. So again, this is a sharp corner right here, and so that sharp corner means that the derivative doesn't exist there. We don't have a slope there, and so that's why we're graphing an open dot on our derivative function. So our derivative ends up looking like a piecewise function. It is a piece of two different horizontal lines. Now for part B, we want to write an equation for f prime. So since f prime is piecewise, we'll write a piecewise function. We'll start on the left-hand side, which is a horizontal line of y equals -1. And we know that we'll have a horizontal line if the x values are less than 2. So that's taking care of this part of the graph. And then for the right-hand side, the equation is y equals +1, and that's if the x values are greater than 2, which takes care of this part of the graph. And again, notice that we're not including 2 on either of the pieces. Once again, because on the original graph we had a corner there at x equals 2, and that's why the derivative doesn't exist there. That's why we graphed open dots at x equals 2. So it's important that you do not include 2 in the derivative function.